In this demonstration, I'm going to launch a distributed denial of service or DDoS attack against a web server. I'm going to do it using the Mirai Botnet. The Mirai Botnet was a DDoS attack that targeted Internet of Things devices, devices that had IP addresses on the internet that were not traditional computers or servers. They were things like web cameras or printers or routers, any type of device that had an IP address that used a default username and password like admin. Now, in this DDoS attack, I'm going to use a safe version of the Mirai Botnet. Now, it's safe because it's not really spreading malware and exploiting machines. The scripts that were written were designed to work in a controlled lab environment or classroom environment. So we've called this the Safe Mirai Botnet DDoS attack. Now, how it's going to work is I'm at my PC and I'm connected to a switch, and I have Raspberry Pis also connected to the switch. We're going to use a Raspberry Pi for the target web server, as well as 4 Raspberry Pi nodes that will make up the botnet. Now, this botnet will be controlled by the attacking device, which is also a Raspberry Pi. Now, the attacking device will have a web browser-based interface running a Node.js server. And you can see it right here. I have an SSH PuTTY connection to the attacker Raspberry Pi, and I've started the node server. So you can see here I've got this server interface. Now, all of the other devices, these other nodes, are also Raspberry Pis. So let's take a look now. If I open up my browser, if you want to know what this looks like in my lab, I have a photograph of it. And you can see here that I have 6 Raspberry Pis. This is the attacker Pi. This is the target web server. And these are the 4 nodes. They're all connected to a switch. And then this blue cable runs to my Windows 10 PC. So the attacking Raspberry Pi has started. So what I can do is open up my web browser and look at the browser-based interface. And you can see here it is, the Safe Mirai Control Panel web browser interface. And I'll start a scan and scan the network to see if there are some vulnerable nodes, which in this case are those Raspberry Pi node machines. And we'll see if it can find those nodes and log into the nodes because they're using a default username and password of admin. The attacking Raspberry Pi has found some machines. It's found 1.5, 1.6, looks here like it's found added node 1.4, and we should see some nodes get added shortly. You can see it's added node 1.4, it found node 1.6, it found node 1.7, and I'll stop the scan and start it one more time to see if we can find host 5 as well. There's host 5. Okay, it added 1.5 to the list. So now I'll stop the scan, and there are the 4 nodes with default username admin and password admin, and you can see that it's targeting port 23, which is a telnet server. The target web server is right here. You can see it here. It's running a simple Python web server. And I'm also going to open up a second PuTTY connection to this web server, to the target, and run a TCP dump so we can see packets being captured. So I'm going to run this TCP dump here, and then I'll put in the IP address of the target web server. And the port number, which happens to be 8000, that the web server is running on, and we're going to send 1,000,000 packets to it. Now, the web server's web page looks like this. So the target web server, it has this web page with a graphic here about the Internet of Things. And in Firefox, I'm going to open up a fresh window, delete this, and what I'll do is I'll clean out my cache, and we'll see how long it takes for, once the attack is started, for the server to respond. So here we go. We've got a fresh window here. Okay, and I'll put this in. We're going to see how long does it take to bring up the web page once the attack starts. Okay, so to launch the attack, I just click Attack. And you can see it's sending information to the nodes, telling the nodes to start a DDoS attack. You can see over here that it's being bombarded. 1.4, 1.5, 1.7 are sending packets to it. And now we'll see if we can bring up the web page. As you can see that the web page came up, but it's missing the image. Oh, finally, here comes the image. You can see it's having a hard time loading the web page in what should have been instantaneous. You can see it's having a hard time loading this large image file because the server is being bombarded. You can see it's taking some time. Right, if I opened up a fresh browser and tried to bring it up, you can see it's having a hard time responding and loading the image. Here we can see the SYN packets, the three-way handshakes trying to be finished here from host 1.6 to 1.8 on port 8000. You can see it's having a hard time replying. Notice how long it's taking. So it looks like the attack worked and the server has been crippled and can't load the full web page because of the millions of packets being sent from the 4 separate Raspberry Pis. Even though the attack is stopped, the TCP timers cause the server to use resources to keep tabs on all the half-open SYN connections that haven't timed out yet. Now, the Mirai Botnet was created by some 20-year-olds who were, their original intention was to launch DDoS attacks against a Minecraft server. However, they ended up using it for more nefarious purposes and even released their code to the wild, and people started launching, and this is in 2016, DDoS attacks against a major DNS service provider, a well-known university, and a country's internet infrastructure. Those companies that were affected were not able to maintain availability to their customers and created a situation of huge financial losses. All right, looks like the attack is now over. Let's see if we can finally get that web page to come up. I'll try to shut down the attacking machine. I'll put in look for the process that's running the master Python attacking server. Here it is at 20,160. I'll kill it. And then see if I can get to that web server. And you can see the web server is not even able to respond at all. Looks like to really get this web server to work even, I'm going to have to restart it. Looks like it's errored out. It looks like the web server's crashed actually. I'll have to restart it. So it looks to me like it's actually really done its job quite well in causing harm to the web server. After restarting the target Raspberry Pi, I'll relaunch the web server. Now I can go back to my web browser and refresh the browser, and you can see that the target web server is back up and running.